I would like to introduce to the stage now Dr. Judith Curry. Dr. Curry is the president of the Climate Forecast Applications Network. She is Professor Emeritus, if I'm pronouncing that correctly, from Georgia Tech's Atmospheric Science Department. She's the author of numerous publications in the arena of Earth and atmospheric sciences. Her most recent book is a topic of reassessing the climate risk that we're facing and how we deal with that. The reason I followed Judith for a while, and the reason I was excited to have her come, is she's someone who comes from the climate scientist, who has a thorough understanding of these topics and has a much more balanced perspective of the risks that we face and the different ways we may face those. So with those, thank you very much, Dr. Curry. We look forward to your talk.
Thank you very much. I'm delighted to be here today to participate in this event. And wow, what a crowd. I'm amazed. I'd like to start with a personal statement to provide some context for what I'm going to say. My job as a scientist is to critically evaluate evidence and question and reassess conclusions. I've spent most of my career as a university researcher and faculty member, most recently at Georgia Tech. I'm currently president of Climate Forecast Applications Network. My company provides weather and climate forecast information to help businesses and governments understand and manage their weather and climate-related risk. So my perspective combines a strong academic research record with real-world experience in assessing weather and climate-related risks. Here's what I mean by an honest conversation about climate change. A conversation that clarifies the uncertainties and areas of scientific disagreement and acknowledges what we don't know. A conversation that realistically conveys the risks and the appropriate management strategies that are commensurate with the risk. Here's the climate change narrative that is supporting the United Nations agenda. The Earth's climate is warming. A warming climate is dangerous. We're causing the warming by emitting CO2 from burning fossil fuels. So we need to prevent dangerous climate change by eliminating CO2 emissions. This narrative is conveyed with great certainty, along with apocalyptic rhetoric from UN and our national leaders. Here are some of my favorites. The clock is ticking towards climate catastrophe. We're on a highway to climate hell with our foot still on the accelerator. The urgent threat of a changing climate. It's an existential threat. The UN Paris Agreement targets net zero emissions by 2050 to keep warming within 1.5 degrees centigrade, or 2.7 degrees Fahrenheit. Policymakers and others are grappling with a number of issues in addressing the net zero challenge. These include the technical, economical, and political feasibility, the priority of climate change relative to other problems, and unintended consequences of a rapid transition of our energy systems. Some recent headlines that I've spotted: Germany permanently damaged from energy crisis. European farmers angry at climate policies. Rich countries' climate policies are colonialism in green. So how did we come to be between a rock and a hard place on the climate issue, where we're allegedly facing an existential threat, but the proposed solutions are both unpopular and infeasible? Well, in a few words, we've put the policy cart before the scientific horse. In the 1980s, the UN Environmental Program was looking for a cause to push forward its agenda of eliminating fossil fuels. With the help of a small number of well-positioned activist climate scientists, a 1988 UN conference in Toronto recommended that the world reduce CO2 emissions by approximately 20% by the year 2005 as an initial global goal. 1988 was a year that the UN established the Intergovernmental Panel on Climate Change, or the IPCC. The first assessment report from the IPCC in 1990 concluded that the recent warming was within the magnitude of natural variability. Well, that didn't hinder the UN. They went ahead with the 1992 treaty from the UN Framework Convention on Climate Change. This was signed by 196 countries, including the US, to prevent dangerous human-caused climate change from emissions. The second IPCC assessment in 1995 found pretty much the same thing. However, in the meeting with policymakers to write the summary, there was substantial pressure for a stronger finding. They came up with the word discernible and then went back and changed the body of the report to be consistent. At that point, the IPCC lost any pretense of being independent or uninfluenced by politics. Apparently, discernible was sufficient to justify the Kyoto Protocol. Even if you don't pay much attention to the climate change issue, you've probably all heard that 97% of climate scientists agree. Well, here are the indisputable facts that all scientists actually agree on. Surface temperatures have increased since 1880. Humans are adding carbon dioxide to the atmosphere, and carbon dioxide and other greenhouse gases have a warming effect on the climate. However, there's disagreement and uncertainty about the most consequential issues. How much of the recent warming has been caused by humans? How much the planet will warm in the 21st century? Whether warming is dangerous? And whether urgently eliminating fossil fuels will improve human well-being. Nevertheless, we're endlessly fed the trope that 97% of climate scientists agree that warming is dangerous, and that science demands urgent reductions in CO2 emissions. Let's look at the issue of whether the recent warming is natural or caused by humans. The figure in the upper left shows the anomaly of yearly average global average temperature since 1850. While there's an overall trend of warming, you can see substantial year-to-year fluctuations and also decadal scale variability. There was substantial warming in the first half of the 20th century before fossil fuel emissions were large. This was followed by a hiatus in the warming during mid-20th century. These variations were associated primarily with changes in the large-scale ocean circulation patterns. The modern warming starts in the late 1970s. This timing coincides with a major shift in Pacific Ocean circulation pattern. And during the second half of the 20th century, we also saw a grand solar maximum associated with the strongest effects from the sun for the past 1,000 years. Volcanoes also play an important role. During the first several decades of the 1800s, there were 3 explosive volcanic eruptions, including Tambora, which produced a year without a summer. Volcanoes typically inject substantial amounts of sulfate particles into the upper atmosphere, which then reflect sunlight and cause cooling. There were several notable volcanic eruptions in the 20th century, but nothing like the big ones in the early 1800s. However, in 2022, there was an extremely unusual volcanic eruption. The Hunga Tonga volcano in the tropical Pacific is about 500 feet below sea level in the ocean. When it erupted, it ejected substantial amounts of water into the upper atmosphere, which then vaporized. And this caused a warming spike, since water vapor is a major greenhouse gas. So the recent temperature spike in 2023 and 2024 was mostly caused by the Hunga Tonga eruption. The figure in the lower right provides a longer-term perspective. This shows the geologic reconstruction of the temperature record for the past 11,000 years, after the end of the Ice Age. The warm period, 8,000 to 6,000 years ago, is called the mid-Holocene climate optimum. Following this warm period, there was gradual cooling and then more substantial cooling between about 1350 and 1850, which is known as the Little Ice Age. The recent warming and the warming targets, such as 2 degrees centigrade, are referenced to the period at the end of the Little Ice Age, which was the coldest period in the last 10,000 years. At the right of the diagram, you see a spike from the modern warming. But because of the coarse temporal resolution of the geologic record, which is 300 to 500 years, there's no way to tell whether a 50-year warming spike is unusual, and it almost certainly isn't. Looking into the future, under the normal course of events, we would expect another ice age in several thousand years. So just by looking at the temperature data, there's no way to tell how much of the recent warming is natural versus human caused. This is where climate models come in, since climate models can reproduce all of the modern warming with the observed increase in carbon dioxide. Many people are convinced by climate model simulations because of their complexity. However, there's a factor of 3 uncertainty in the most fundamental aspect: the sensitivity of global climate to a doubling of atmospheric CO2. The red bars in the diagram show the range of climate sensitivity estimates from the global climate models used in the most recent UN assessment report. If climate sensitivity is on the high end, then natural climate variability is relatively unimportant. However, if climate sensitivity is on the low end, then natural variability is very important. Apart from the substantial uncertainty about climate sensitivity, there are additional inadequacies in climate models. Climate model simulations for the IPCC neglect plausible solar and volcanic forcing scenarios, and they have limited ability to simulate large-scale ocean circulations, and so they show poor skill on regional scales, and they can't resolve most types of extreme weather events. The bottom line is that climate models aren't fit for the purpose of assessing how much of the recent warming is natural versus human caused, or how the 21st century climate will evolve. The amount of future warming also depends on projection of future emissions. The figure on the left shows different emissions scenarios used by the UN out to 2100. The extreme emissions scenario in purple is associated with 8 degrees warming by 2100. In my opinion, the most significant development in the past 5 years is the growing acceptance that the extreme emissions scenarios are implausible. These extreme emissions scenarios have been abandoned since 2021 by the UN climate negotiators, as shown in the diagram on the right. The medium emissions scenario, 4.5, has been adopted as the current business as usual scenario. Nevertheless, scientific research, national climate assessments, and even the IPCC continue to emphasize the extreme emissions scenario with unrealistically high temperature projections. The next source of disagreement is whether warming is dangerous. In my opinion, this is the weakest part of the apocalyptic climate narrative. In order to get to dangerous, you need to rely on the extreme emissions scenario with 8 degrees of warming. But we've just seen that the UN climate negotiators have now rejected the extreme emissions scenario as implausible. The most unambiguous impact of warming is sea level rise. The figure in the upper right shows the historical global sea level rise. Since 1880, global sea level has risen by about 9 inches. The rate of sea level rise is about 3 millimeters per year. For reference, 3 millimeter is the height of 2 stacked pennies. For the medium emission scenario, the UN predicts a sea level increase of 4 to 15 inches in the first half of the 21st century. In 2025, almost all of this predicted, in 2025, almost half of this predicted sea level rise should have already occurred. So let's take a look at the sea level rise history for Galveston, the diagram in the lower right. You see a steady increase since 1905, although there's year-to-year and decadal scale variability. The sea level rise in Galveston is occurring at a rate of 6.65 millimeters per year, more than twice the global average. The reason is that Galveston is sinking, mostly from the extraction of groundwater, oil, and gas. Even with all that sinking, Galveston's rate of sea level rise is on the lower end of the IPCC projection. So the UN sea level projections seem too high based on what we've seen in the first quarter of the 21st century. The public is most alarmed by extreme weather events because of their immediacy and readily apparent impacts. The media and some scientists blame every extreme weather event on fossil-fueled warming. However, these statements are not consistent with the most recent UN assessment report. For the medium emissions scenario, the greatest confidence for impacts is an increase in extreme heat events and a decrease in extreme cold events. There's low confidence in the direction of change for heavy flooding, drought, hurricanes, tornadoes, and hail. The diagrams on the right show indices of extreme weather events for Texas. The top diagram shows the drought index. You can see a lot of year-to-year and decadal variability, with the worst droughts occurring in the 1950s. The bottom diagram shows major hurricanes that have struck Texas, most recently Hurricane Harvey in 2017. You can see that there were more major hurricane landfalls in the first half of the 20th century than we've seen in the most recent 50 years. The bottom line is that there's little evidence to support increases in most extreme weather events. You don't often hear about the benefits of global warming. In the satellite era, since about 1980, the planet has been greening. This benefit to forests and agriculture is caused mostly by increasing carbon dioxide in the atmosphere. Plants like CO2. It's well known that globally there are more deaths from extreme cold than from extreme heat. So rising temperatures are associating with the net saving of lives owing to the reduction of deaths from extreme cold events. Further, the IPCC report states how heat-related mortality is declining over time, owing to general improvements in healthcare systems, increasing prevalence of air conditioning, and behavioral changes. Other benefits include economic gains for northern regions and more rain in the Asian monsoon region. So to summarize, the climate crisis isn't what it used to be. The extreme emission scenarios have been abandoned by UN climate negotiators. The most recent IPCC assessment report recognizes that many climate models are running too hot. UN climate negotiators are working with an expected warming of 4.3 degrees Fahrenheit by 2100. This is half the warming that was expected only 5 years ago under the extreme emissions scenario. 5 years ago, 4 to 5 degrees Fahrenheit of warming was regarded as climate policy success. And 2.3 degrees of this warming, more than half, has already occurred. Instead of acknowledging this good news, UN officials continue to amp up the apocalyptic rhetoric. The rationale for continuing to increase the alarm is that the impacts are worse than we thought, specifically with regards to extreme weather, which we've seen isn't the case. You would logically think that if warming is less than we thought, but impacts are worse, that the priorities would shift away from CO2 mitigation and towards adaptation. However, that hasn't been the case. So how should we think about the climate change problem and its solution? The UN views this as a simple, tame problem, framing climate change as being caused by excess carbon dioxide in the atmosphere, which can be solved by eliminating fossil fuel emissions. Both the problem and solution are included in a single frame, whereby the science demands this particular solution. This framing dominates the UN negotiations on climate change. Here's an alternative perspective that views climate change as a wicked problem with complexity and uncertainties, along with clashing societal values. This perspective shows two separate frames, one associated with the causes of climate change and the other associated with solutions that can help reduce vulnerability to climate change. The larger frame on the right includes both natural and human causes for climate change. This framing is provisional, acknowledging that our understanding is incomplete and that there may be unknown processes influencing climate change. The frame on the left is about controlling the climate as a tame and simple problem, whereas the frame on the right acknowledges the futility of control. Solutions on the right side focus on managing the basic human necessities of energy, water, and food. My own understanding is squarely in the frame on the right. So how should we view climate risk? This diagram summarizes the UN view encompassing the apocalyptic climate narrative. Under this perspective, climate change is a big umbrella that causes many of the world's problems and subsumes energy and extreme weather policy. The apocalyptic perspective is reinforced by a broader globalist view that we need global control of this issue. The right-hand figure provides a different view, which is more consistent with a human-centric perspective and the UN Sustainable Development Goals. Further, this view is consistent with human flourishing and thriving to meet the challenges of the 21st century. Most importantly, this view regards climate change, extreme weather, and energy policy as three separate issues, albeit with a small overlap. Energy policy is regarded as primary, since abundant energy is needed to spur human development and to manage whatever challenges from extreme weather that we may face in the future. Once we separate the risk of slow warming from the risks associated with extreme weather, the problems and their solutions become more tractable. My book, Climate Uncertainty and Risk, argues for a reset of climate and energy policy that's consistent with the human-centric perspective. First, we need to face some inconvenient truths about climate risk. Risks from climate change and extreme weather are fundamentally local. The risks are entwined with natural climate variability, land use, and societal vulnerabilities. Blaming weather catastrophes on fossil fuel emissions deflects from the real causes of our vulnerabilities, which includes poor risk management and bad governance. And finally, many people fear a future without cheap, abundant fuel and continued economic expansion far more than they fear climate change. There are also inconvenient truths about the UN climate and energy policies. The urgency of meeting net zero targets is causing us to make bad choices about future energy systems. And even if we somehow manage to reach net zero by 2050, we'll notice little, if any, change in the climate before 2100 relative to natural climate variability. Given that the UN has mischaracterized climate risk, it'll come as no surprise that we are mismanaging the risks. Climate pragmatism seeks to accelerate energy innovation, build resilience to extreme weather, and no regrets pollution reduction. It's an approach that emphasizes agreement on solutions and doesn't require agreement about climate science or the risks of uncontrolled greenhouse gases. It addresses local problems with local solutions that secure the common interest. It focuses on solutions that are feasible, politically viable, affordable, and that have no regrets. The approach provides near-term benefits and has justifications independent of climate change mitigation and adaptation. And finally, it avoids political gridlock, costly policies with minimal impact on the climate, and policies with adverse unintended consequences. Our current energy policy is focused on kneecapping fossil fuels. Once you separate energy policy from climate policy, a rational way forward for energy policy becomes fairly straightforward. We can all agree on the goal of providing abundant, secure, reliable, cheap, and clean energy. The 21st century energy transition can be facilitated by accepting that the world will continue to need and desire much more energy, removing the restrictions of near-term targets for CO2 emissions, developing a range of options for energy technologies, using the next 2 to 3 decades as a learning period with intelligent trial and error, and evaluating the technologies holistically for abundance, reliability, life cycle costs, and environmental impacts, land and resource use. Without focusing on CO2 emissions, odds are that this strategy will lead to cleaner energy by the end of the 21st century than by urgently attempting to replace fossil fuels with wind and solar. My book, Climate Uncertainty and Risk, provides a framework for rethinking the climate change problem, the risks that we're facing, and how we can respond. By acknowledging uncertainties in the context of better risk management and decision-making frameworks, there's a broad path forward for humanity to thrive in the 21st century. Thank you.
Thank you, Dr. Curry, for the talk. It was fascinating. I think at this time for about 10 minutes to take a couple of questions from the crowd. And I have 100 of them, but I'll kick off with a first one, which is, within the, say, consensus climate scientists, all you ever hear about is the negative impacts of increasing temperatures. And it seems very obvious that there would be many positive impacts that come from this as well. And why do you think that is? We have many friends from Canada here this evening who I think would probably appreciate, longer spring and summer seasons. It feels like humans gravitate to the south where things are warmer. Why is it that within the mainstream consensus there's no talk about the offsetting benefits and costs?
Well, it's basically been, the science policy, the policy card out in front of the scientific horse. Once this policy goal of, eliminating fossil fuels was pushed forward by the UN, then the scientists were charged with looking for dangerous human-caused climate change. They weren't asked to understand natural climate variability. They weren't asked to understand the benefits of warming or additional CO2. So it was, politics all the way down, unfortunately.
Dr. Curry, it was great that you're here. Been a fan of yours for a long time. And you stood in the face of, canceling back in the day, back in 2010, 11, 12, as we saw the peak of, the anti-fossil fuel movement. ESG, being called climate deniers, all the things that we in the fossil fuel industry have been subject to really hard over the last decade. Are you experiencing a shift in that narrative today versus when you were really standing in the heat of battle as a scientist, pro-science, as opposed to just going with mainstream media? Are you seeing a different narrative today?
Yes, but my biggest sin and why I was caused a denier was for criticizing the behavior of activist scientists, playing politics with their science, trying to keep data out of the hands of people that might criticize it, and it was basically criticizing their behavior. And I was talking about natural climate variability and uncertainty, and this was very inconvenient to the apocalyptic narrative. And one person, Michael Mann, said, I know how to deal with the Judith Curry problem, just call her a denier. Okay, and then that took off, and it became okay to call serious climate scientists, climate deniers, if they disagreed with Michael Mann. I see a shift where scientists are increasingly understanding that this is a very complex issue, and policymakers are understanding that there's no silver bullet solution here. So people are really more open to the idea of uncertainty and complexity, and I think we're, the whole cancel culture thing is not as profitable as it used to be. So, especially with Elon Musk and Twitter has been a big thing, and now with how the current administration is going to play out exactly on this, I don't know. But the current administration does seem to have a much more rational approach to energy policy and hopefully to climate policy.
Well, thank you, Dr. Curry. Dr. Curry, again, that was an excellent and fascinating presentation. I think, join me in a round of applause. Thank you.